Hey everyone, I'm doing something a bit uncommon today in this video and making a recording the day after I've closed out working on this product for a customer. And I just kind of want to preface this video because it is a bit negative towards the product that I have right here. Now, it is a Klipsch subwoofer, and typically I don't have negative opinions of many things. I think pretty much everything is repairable, barring time, which includes being patient, availability of data to a certain degree, availability of parts, and, just average typical things you think about when it comes to repairing a product. Yes, all things can be repairable, right? But sometimes you have to take a step back and you have to ask yourself, should it be repaired? Especially when you own a business, especially when you own a business where when you repair something, it's not a repeat business. You don't want a customer to keep coming back over a product. Unfortunately, I believe this one right here will be one of those products. Now, a customer reached out to me looking into the feasibility of repairing his Klipsch subwoofer, which we will look at today. And in the past, when I've repaired other Klipsch subwoofers like the SW450, it's been power supply issues. Caps that have gone bad, and you know what, these are older subwoofers, and so that's easy repair, very low cost, quick turnaround for the customer. No audio amplifier section repairs have I run across yet until this time. So when we were discussing, the individual also keyed me up on the fact that this is a newer product per se, and a lot of them are starting to come back, and there's a growing online community grumbling about this product, and rightfully so, because they are failing. Now, what I'm going to do in this video, I've titled it Analysis, for obvious reasons that you'll find out when you watch this. And to be honest, this video, in my analysis and what I am doing in it, it ended up costing me somewhere between $700 to $800 because of certain things I did that took out some of my test equipment. Okay, not something that I'm passing off to the customer because I should have taken a little more precautions before I worked on this device. Now, as far as the analysis goes that you see in this video, I've been doing electronics now for over 20 years. I teach electronics in my current job. I'm not an engineer. I'll never claim to be one. I do have quite a bit of education, but it's in other areas. A lot of things I learn about electronics have been by experience. So I'll go ahead and preface that. I also know within the industry I am in and for the government, when it comes to actually analyzing certain components to the point that they fail, right? When you're trying to determine life cycle and cost and supply and all those other things, you actually take a product, you put it on a bench, and you're going to put it underneath a lot of duress and stress and drive it to the point of failure. So you need to gather a lot of data, you need a lot of expensive test equipment, and things of that nature that I really just don't have here to do that form of analysis. So the type of analysis I'm doing on this video is more of an overhead analysis. I'm looking at parts, I'm testing voltages, and then I start digging into more, how does this IC or this device function? What does it need in order for it to be coupled together with other components on the board? Are some of those things being met? Unfortunately, I don't think there is within how this product is engineered. But you will see that come out in the video, and then I'll give you my final thoughts in this fashion again at the very end of it. So let's dig into this. Hello everyone, welcome back to the channel. I've got an amplifier, actually subwoofer amplifier here in need of repair, potentially. This is a Klipsch RP-1600SW, comes from the 16,000 series line. A little bit of a higher profile, or I guess subwoofer from the SW line, like the 450s you've seen me on this channel work on in the past. However, operationally, it's really no different. AC comes in, you have your line in, but you do have a WA 2-port available as well. You can do your phase 180 degrees out if you want to, auto on, standby, full on, or just a hard set for an on. You also have your frequency adjust, see your low pass filter settings right here, and gain. So that's no different than SW450. If we were to look at the bottom side topology, and I'll try to turn this around a tad bit and briefly walk you through this, okay? So AC comes in on this side, all right? We're gonna have rectification here. I can actually already see we got full wave bridge rectifier here, as well as some additional either MOSFETs or DC to DC rectifiers sitting right here. By view of this transformer, and then a smaller one here. Oh, we got another one over here. Okay, so big old safety cap. All right, and 1, 2, 3 optocouplers. So essentially, I think we've got 3 separate DC lines of rectification, if I could put it that way. It's probably not the most appropriate way. But on one side, we are developing a positive 15 volts. It looks like over here on this second circuit, you know, all this derived from the unregulated DC that's being developed over here. We have a positive 15 and a negative 15 rail. Looks like switching for power on. And then I'm going to assume that this top side is developing another voltage, although I'm not seeing a cable except for right here. Here we go. Ground, V plus and V minus. So this is probably going to be upwards of 20 or 30 or 40 volts, maybe 50 volts. So yeah, one stage of rectification, I'll put it that way, from AC to DC. Then we get unregulated and we're developing no less than three separate DC to DC converters per se. All right, so all that is there. This is the bulk power supply, taking those DC voltages up to this board that you see on top, which in turn is taking our audio from whatever source. You know, these down here or this guy there. I've actually never seen that before. That's kind of like a PS2 port that you saw on computers. I think I've seen this. It's very similar to S-Video, but the pinout's different. I don't know. Yeah, you can do. I've seen old cameras, security cameras, had like a port similar to that. Anyways, so we've got our audio coming in. We can see that down here on this board. So it looks like we have some probably transient surge protection or something along those lines. We got potted components here. Yeah, good luck getting all this potting material off. That's really silly. But then audio traveling up to this board. We'll do our filtering. We'll do our audio phase shifting. All that kind of stuff happening around over on this side right here. And then it will be amplified over here. Actually, that's why we got this big old heat sink right here. Probably a pair of push-pull Darlington transistors, doing the amplification before putting it out over the driver or woofer or subwoofer, whatever is used. Obviously, it's being for base a subwoofer itself. All right, so that's kind of the overview, quick, dirty, and maybe not 100% accurate, but the quick and dirty overview of what's going on here. Am I very impressed just by what I'm looking at here in the RP-1600 series Klipsch subwoofer? No, I am not. This is the same shenanigans you see in SW450, cheap power supply boards. Capacitors that maybe bulk purchased, generic. I mean, I'm not really too sure. KETUO. I'm not sure the lifespan of these electrolytics I see on here. I mean, I'm not saying that the components I see on here are necessarily bad. They're just not common in what you would see in high fidelity audio products. That's all I'm saying here. Additionally, you know, this, by the size of that transformer and everything, I mean, it's a decent power supply. Typically, you would have your power supply shielded, so that way there's no, say, AC hum or anything that gets inducted, maybe across these coils that you have over on the audio side. So I would expect in higher end products for there to be additional shielding. But everything is heat sinked, and that needs to be heat sinked. And we got what do you call that stuff? Heatsink compound, the white stuff in behind our transistors. Actually, there's another full wave bridge rectifier there. So yeah, are we getting two AC sources? Maybe stepping down the AC here for an unregulated here coming out, and then a separate unregulated here for developing these voltages. That's kind of crazy. I mean, it's a subwoofer. It's going to provide you some punch, some loudness, and hopefully not blow the speaker or the subwoofer, which gets into why this the individual sent this to me, because it stopped working operationally. Now, he believed initially that it has to do, and yes, I got my rings and jewelry on. I'll take that off before I get into this. He believes that the problem initially occurred here because he turns it on and nothing's happening. Again, I don't see any LEDs specifically on this. If it's like the other Klipsch subwoofers, there'd be a little Molex or you know, 2-pin connector that would go somewhere on here to feed an LED to show you whether it's on or off. Digressing a bit though. Where was I at? Yeah, he believed that the issue was most likely here, but after shipping this out, he took the driver, the subwoofer out, and just took the subwoofer to a different speaker setup to test it out, because he didn't have a multimeter, couldn't check to see there's continuity across the voice coil, and the speaker would not produce sound. So I don't know if this will be a repair video or not per se, but we'll at least power it up. I'm going to get a 80 hertz sine wave injected into this, and then at our speaker outputs here, which were snipped, we'll take a probe to our oscope and just look to see if we have a sine wave. So that's what we're going to do. Initial test to see if this does function. Might play with it a bit if it does, and but if it doesn't, then yeah, we got troubleshooting to do. So let me get things connected. All right, so I've got AC coming now into our board. This is kind of a vicarious setup here. Let me move this up this way. There we go. AC coming in right down here. Now feed it in. Don't have my SIGGEN turned on. Let me turn that on. We're going to set it for 80 hertz. We'll do an amplitude. Let's do a lower amplitude. Let's just do 0.5 volts. All right, we'll turn channel 1 on. There we go, it is on. All right, let's turn this off. All right, let's turn this off. Automatically got an issue. Overdriving badly. Overdriving. Ooh, that might have just blew up my SIGGEN. I think that smoked my SIGGEN and my O-scope. Oh no. Well, unfortunately, you saw it there real time. I should have put this on a dim bulb tester first. That has smoked my SIG generator and my oscilloscope, and neither are working at all. Something has gone seriously wrong in this thing. Let me see if I can get some things reset, hopefully salvage my test equipment, and see what's gone wrong in this guy. Okay, so the question is going to be now, what went wrong? Because this was spectacular failure. And, well, first off, that completely smoked my SIGGEN. It don't stay on anymore. And even though my O-scope turns on, there's no display, and I get no connectivity or communication to my PC, so it is smoked as well. Now, I want to go ahead and admit to something. Typically, when I am working on an amplifier and I don't know the state it is in, ignore everything that I'm working on that's throughout my office, I'll have it plugged into my dim bulb tester. So there's an excessive current draw. That incandescent bulb you see right there, it's going to illuminate and let me know something big is wrong. And so I thus have 3 immediate kill switches. One at the dim bulb itself, usually kill power there, or at my variac, or at my isolation transformer. And in my haste to kind of get this gentleman an answer after hearing that his voice coil was bad, I took a risk, and that risk was very costly. So now we're going to see what is actually going on with this. Do we have a massive power supply failure, or do we have a failure on the audio amp section? And I'm thinking more on this side, maybe a little bit to do with this side. I'm not too sure yet. Probably to do with our push-pull Darlington transistors, amplifier transistors down at the bottom. Because what is going to cause so much feedback that it actually burns the output of what I'm using to eject a signal onto the RCA input right up there. That makes 0 sense to me unless we have something massively wrong over on this side. So I've got the fuse pulled out. We're going to check it. We're going to check some things, and we're going to determine, because this was costly to me, and like I said, that's my mistake. But we're going to determine what is going on with these Klipsch RP-1600 subwoofers, because I talked to the guy again, and lo and behold, many people are having their 1600 series amps go bad, and I kind of want to help out the community here. So if you are watching this video, and I'm not charging the customer for my mistake, just so y'all understand that. He's going to pay me for what I've worked on here in my time, and he fully understands that. But if you're watching this video and you're a part of the Klipsch community, I want you, please subscribe, share this video, get the word out, because we're about to uncover what is going on with these and why so many of them are breaking. According to the customer, a lot of people are having issues with this, and I want to know why. Because if it's cooking an audio at the input, that means that it's probably frying people's receivers as well, at least their preamp sub outs. That's the only thing I can think of. There's no way that should have gotten cooked by it being plugged into the RCA connector on there. That makes 0 sense to me. Cooking my O-scope? Sure. Over amplification. Got that. My stupidity not having this plugged up to my dim bulb tester? Okay, I can get that if we have a power supply issue. But we got to determine, is there a power supply issue or is there an amplifier issue? So let's dig into this a bit. Okay, first things first. Let's check the fuse at the AC input. Hey, AC fuse is not blown. There goes number one strike. If we are overdriving our audio to the point of absolute failure like that, why, oh why, are we not pulling so much current from the power supply that our AC fuse doesn't blow? Okay, so that's going back in there. Let's plug that in. AC fuse isn't blown, and I believe that there is a second fuse on the power supply board, and there is F1 sitting right here. Is this fuse blown? Let's find out. No, not blown there either. Are there any more fuses? Not from where my eye can see. So, okay. Well, if we're overdriving here, that means that we're pulling from a regulated DC on our DC side of our power supply. If there's too much current coming from the DC power supply, that means that there's too much current coming from the rectifier section, which means that it should be detected on the AC side. Those fuses should blow, or you need additional fusing in between each stage from unregulated, maybe not unregulated, but at least on your regulated side. That makes no freaking sense to me. But again, I mean, we saw much of the same with the SW450s. They're not fused on the regulated side, at least from not what I've seen. Now, I want to show you all something. This is just a little sidebar. These are really secure terminals, okay? They are hard to get off of the board. I'll just go ahead and let y'all know that. He clipped his. I tried to explain this a bit how it works, but really, you've got a center tab here, and you can, and I don't have this plugged in, so I'm okay right now. You've got to get something underneath here to lift up this tab. I'm going to use this screwdriver and very carefully. That centerpiece pops up, and then they just slide off. That's really simple. Okay. Like I said, we've talked on the phone since in between certain parts of this video. He knows I'm not going to repair this at this point. He's a bit on a time crunch to get this item back, whether it's repairable or not. And even if I desire to repair it at this point, I mean, really, we're just exploring why this thing failed, and I would not be recommending this product to anybody. Okay, same thing on this side. I can just kind of get my finger up underneath there, and then I should be able to rock it out, so long as I'm on that center pin. Well, this one's being slightly more difficult, but I might have to use something else, like some needle nose pliers. Alright. If you can't get out through this side because of the components, that's fine. You can do certain things like getting your pliers right in here and lifting up that tab. Actually, we can get it from the side. There we go. We'll get it from the side. All right, tabs lifted up. Now that I've gotten lifted up, I could probably grab it just like that, and yes, slid off. All right. They do these kind of locking terminals because when you're in a subwoofer, this is actually good. I'll get Klipsch props here. There's a lot of vibration, and you don't want this vibrating at all, because these are your wires that are going to your sub. Any break in continuity is going to decrease performance of the sub. You'll miss beats. I need to get back on focus. Okay, so fuses are good. Let's go plug this into my dim bulb tester now that the fuse is in, and just see what happens when it powers up. Okay, and like I said, I should have done this
instead of rushing, because I've worked on so many I got careless. This was my bad. Isolation transformer, 120 volt AC. Ooh, and immediately, did you catch that light? I wonder if that fuse is cooked now. Kind of don't want to touch the chassis given what happened last time. And we see it right there starting to brighten up. So we don't have a direct short. We're drawing a bit of current, but it's not shorted. So that's telling me that we probably don't have an issue with the power supply section. So is it going to be on the amplifier section? I can't inject a tone into this. I already know it's going to blow up equipment. But what I can do is I can disconnect things from the power supply, and we'll just check our rectified DCs going to this board and eliminate the power supply from the audio amplifier board. Okay, now I got it back over to the bench. I've still got the AC line cord going to my dim bulb tester. The entire amplifier board has been now completely isolated from the power supply over here. And so through this entire section. And so what we're going to do is we're going to check our voltages on the power supply and just see what we're getting. Okay. We've got ground and 5 volts here on this first plug. Let's see what we're getting. I can keep a steady finger. All right, so our 5 volts is good. We're at 4.997. Okay, we should have ground here and positive 15 and negative 15. I'm going to move this a little bit higher up. I'm going to situate this in a way where it's easier for me to work. And so I'm going to go to the ground rail and our 15 volt rail. Not getting anything there. Nor here. I wonder if this needs a power on to activate. I.e., does it have to be hooked into there in order to get a reading? Let me try this side. Ground, negative 15. Yeah, and I'm not seeing anything there. That actually might have to get hooked back up. Let me check over here, see what we're getting. 0 volts on this side. Nothing on this side. Nothing between the two terminals. Okay, I'm going to completely shut this off. Kill everything over at my dim bulb. Hook this back up and we'll check those voltages again. Give me a second. Okay, I've got everything hooked back up. We can check these voltages again. Let's go to the 5 volts. Ground. 5 volts. And we have that 5 volts still. Let's go from our ground to our negative voltage rail. Let's see, no, that should be positive voltage rail. So ground is down in there. Positive 15. We've got that. What about the negative 15? Do we have that? We have our negative 15. Okay. Now let's check these voltages down here. Here goes a negative voltage rail. Negative 74.7 volts DC. I bet, I'm willing to believe that that is probably fine, but without data, not too sure. 76 on this side. So it's probably like a plus and minus 75 or 80 volts. The power supply is primarily looking fine to me. So I would say that the power supply is good. Our issue is not on this power supply. So regardless of what's happening on the amplifier side, we can say the power supply is good. So we need to find out what is happening on our amplifier side. And let's, you know what? Let me turn this off, and we're just going to take the amplifier side board out, at least down to the Darlington transistors. I want to check out a couple things there. Okay, so I'm starting to tear down to get our amp board out. Heat sinks off the back. You got a little thermal wafer sitting here. This really isn't the best product for transferring heat. You really need a compound like thermal grease or something instead. But if you notice this, what's this oily residue? Y'all see all that? It's not just here, but it's on here as well. That's got my interest. But I need to finish getting this knob off. I need to loosen up these two potentiometers here. And then we should be able to finish getting this out of the chassis here. Okay, now that I've gotten it apart, herein lies our issue. Are you seeing it? No. Never mind that I've bent our NPN transistors and our MOSFETs down away from this shield here. Are you seeing what I'm seeing? Here, let's take a closer look. Now that I got it underneath the microscope. Anyways, can you see the issue now? Please tell me you can see an issue. These things are cooked. I mean, I could take a multimeter to it, but you can already see, man, they have sweated bad. They're cooked, okay? Not to the point of complete failure, but right about there. Now, I'm going to walk you through this kind of backwards and upside down. I realize that I don't have this situated the right way for you. But essentially you have paired MOSFETs, IFR B4227s, followed by tip 31C, NPN power transistors, and then two more pairs of MOSFETs with a NPN power transistor at the far end. And those are coupled with a IRS 2092S. I've seen these before. As a matter of fact, I can show you where I've seen them, because here's the same one right there on Amazon. Same components, essentially $30. I just want you to keep that in mind. Okay. Now, besides the fact that this is just not a high-class amplifier, okay, so they're starting to overheat and sweat. So where's our thermistor at? Okay, let's move to the right. There goes the thermistor. You see that NTCL? You got it right there. There you go. Here's our thermistor. Okay, it's good. Okay, it might have some heat sink compound on it, which is fine, because you would heat sink it to your chassis. That's pretty close to your power transistors and your MOSFET. So if the chassis is heating up right there to the point of failure, that should shut off the system. However, it's not really effective given these things are sweating and we're running into that issue. So maybe all this needs to be reconfigured a bit. I would think that this would not be outside the housing, but situated kind of mid-range between all these power transistors. So like in between the first tip 31C and your let's see, 1 to 3rd MOSFET over, typical topologies, you would see a thermistor in between these two, right in between the entire run. Okay, so this isn't really getting a good sense, even though it is there, of how hot your MOSFETs and your NPN transistors are getting. And that still begs the question, okay, so they're overdriving, but why did my SIGGEN cook at the input? This would explain overdriving and cooking my oscilloscope if I exceeded the voltage at the input of my oscilloscope, which, darn, man, so stupid of me. But why the input? Okay, so I want to just briefly check our tip 31 Charlie power transistors. I've got those two folded upwards and our MOSFETs folded down. They're registered base collector emitter. And because they're NPN, that means that I need a positive on the base in order to see a diode and diode check. Excuse me. I moved that down. I should see something akin to a diode across once we do that. Yeah, I do 0.5. All right, now it's base to collector, base to emitter, same thing. Okay, and then collector to emitter, we shouldn't be shorted. I'm seeing 0.2 voltage drop. I'm not too sure about that. That might be a bit low. Let's reverse our leads now. I'm reversing my leads on collector to emitter. 0.2. Now let's go to base to collector with it reversed, and it should start charging upwards, essentially. 0.4. That looks a bit weird to me. Again, we are in circuit. Alright, base to emitter now. 0.4. Yeah, that's looking a bit weird to me. Let me check this one over here. Doing the same thing. I'm going to put my negative to the base, positive to emitter. So that looks better, 1.8. I imagine that's what it should be in circuit, not that 0.4. And we see that center one starting to rise above 0.1. So minimum, I believe we've got a bad power transistor here. All right, now let me reverse it. I think I'm on the same lead there. Yeah, 0.6. And 0.6. 0.6. Okay, so I think that one's probably going to be fine. With the way these things have sweated the way they have, I would be apt to replace every single one of them. Okay, so MOSFETs, I mean, you can kind of do the same thing if you've seen some other videos, measure gate drain source, but really you want to put an oscilloscope to them. You want to look at the waveform, and obviously I can't do that. I've been blowing up my oscilloscopes. But do have a nice big 8 ohm dummy load that we can put on our speaker outputs. I'm going to power it up again, and I want to take a voltage measurement across our input terminals. You know, obviously no audio applied. I want to see if there's anything there, DC voltage, something that's coming across that shouldn't be there. And then I want to at least make some DC measurements at our MOSFETs. Perhaps we can see a disparity there, or something that will indicate to us that it's potentially bad. Now, that being said, though, there is one other thing I want to address. Okay, you see this IC. You probably can't. Give me a second. I'll move the camera. Okay, there we go. Hey, do you see this IC right here and right here? Okay, those are your, what are they? IRS 2092 audio amplifiers, rated 200 volts max, right? I want to talk about them for a second. Now, these are, well, first off, each one is paired with its own, if I don't knock things over, two MOSFETs in a push-pull configuration to drive the speaker, okay? So I want to talk about the type of MOSFETs that are being used in these audio amplifiers for a brief second. Alright, so I want you to read this right here with me, if I can get it on camera. And if it will, there we go. Alright. Let's top out the switching speed of the 2092S, okay? Internal overcurrent protection has a certain time window to measure the output current. If switching transition takes too long, the internal overcurrent protection circuitry starts monitoring voltage across the MOSFET that induces false trigger of overcurrent protection. Less than 40 nanocoulombs of gate charge per output is recommended. So what is overcurrent protection going to do? It's going to shut things down. It's going to shut certain voltages potentially to ground, and anything that's coming through is probably looking to get dissipated somewhere away from your MOSFETs. Okay. Could also be damaging to your MOSFETs because look, false overcurrent protection. So I want you to keep that in mind because they paired them with these IRF B4227s. Okay, let me pull up some data on here. Okay, now I got it pulled up. Ooh. Bring my camera back over here. Let's see if we can find some more data. Gate source voltage. Where are you at? Not there. Here we go. Total gate charge. Okay. That is Q underscore G or lowercase g. Total gate charge. All right, looking at a type 70, maximum 98. So nanocoulombs. Significantly exceeding what you need for the 2092S or whatever amplifier ICs sitting right here. All right, watches, rings, and dangling things are now off because I got AC, live AC applied to this circuit board. Okay, I have my white RCA cable going into the LFE input. I've got my positive probe going to the center pin of my RCA cable, and then the ground or ring or sleeve is going to be the same ground as the chassis. So as long as I got this here, there shouldn't be any issue. Over to my left, and you can see that I have my 8 ohm dummy load going to this to the speaker out. And so now all I need to do is to turn it on to see if we get any live voltage over that LFE circuit. And no, I'm not seeing anything. So that's at least one good indicator. I'm going to, with it on, start increasing my gain. Not seeing any issues there. No AC either. Alright, so that's good. Alright, let me turn this back off. Okay. Now I should be able to check the pins on my MOSFETs. And I'll turn them back on. Make sure I got a bit of gain. Alright, so let's see. This should be tip 31C and 60 volts there. 60 on the other side. 20 on the center pin. So I'm going to write that down. Let's see. Neg 60. Neg 60. And that was 20. Neg 20. Alright. Neg 60, neg 60, and neg 20. I'm going to do the same thing for the other tip 31 Charlie, neg 60, neg 60 essentially, neg 20. So those read the same. Alright, let's check the MOSFETs. Crap. Neg 74. Neg 70. 0. Okay, let's check the MOSFETs at neg 74, neg 70, 0 on that first one. Neg 74, neg 70, 0. So gate neg 70, drain 0. Source neg 74. Let's see if those are all the same. I gotta be super careful doing this. Alright, 0 on the source of this one. 4 On this one, -75 in the center. So this one was 0. Was that -4 and -75? +4, +76, 476. Okay. Wonder if it'll be the same for these over here. Let's see, this first one, -74, that's the same. -70, that's the same. 0, that's the same. And 0, that's the same. So is this 4 or 5? Yeah, 5. 76. Okay, so they're all reading the same. I said it should be conducting, but until I can see the signal with the O-scope, after blowing my O-scope, I don't know exactly what the signal is looking like. And it could be really, really, really terrible looking. But as of right now, I'm not seeing an issue for why, when I turned this on, unless my multimeter is just not gating fast enough, why it took out my signal generator or my O-scope, because my O-scope is rated for channel 1 400 volt input. So it's just super odd to me. Okay, I'm gonna cut in and amend for a second, because I closed out thinking that there was not an issue, but I decided to actually drive the output a bit more. And so I'm back at -10. By the way, -10 dBm is got my calculator out here. Goes out to 2.2 volts peak to peak. So 0 dBm is 0.6. So that's still a low level audio. So I'm going to do this at -10, which is a lower level audio. And I'm going to show you something. Okay. So right now, we're getting 1.6 volts across our coil here. Okay, 1.6 volts RMS. Now, as I turn up the gain, I need to get this up here. Let's move this out of the way. And as I turn up the gain, I want you to keep your eye on that multimeter. Watch what happens right when we get around 8 volts. Now I'm not even touching it. See how it's dropping out? That's audio clipping. I don't even need an O-scope to see that. Okay, so clipping audio is terrible for subwoofers, and that destroys them. And that is most definitely a transistor and MOSFET or MOSFET/transistor issue. I'm not even fully turned up. I could go up a lot more, and I'm gonna believe that's got something to do with that quasi weird readings I was getting on the output transistors. So at this point, I guess I'm going to message the customer to see what he wants to do, but I'm just going to be honest with him. Excuse me. I don't think the MOSFETs are paired correctly for the digital audio processor. I think you're going to run into this issue again. If you're driving it for very long periods of time, that thermistor being located outside the metal casing that those components are in, that just doesn't seem right to me. I would think that they would be in between all that like they are in other Class D amplifiers. Maybe I'm wrong about that. Maybe I'm not. You let me know in the comments. But yeah, this is probably where I'm going to leave it.
Okay, so like I said at the preface, beginning of this video, I'd come back once I could gather my thoughts and give a closure, so to speak. And enough time has passed away that I actually started working on closing out my AM48 video because I really wanted to gather my thoughts and consider the things that I was looking at on the Klipsch RP-1600SW 800 watt amplifier subwoofer. Anyways, touted on the website, right? It is an 800 watt RMS amp, 1600 watts peak over an 8 ohm speaker. I want you to keep that in mind. And I kind of want to use an analogy for in this, and I'll do that more towards the end. But I want you to consider, you know, as far as circuit designs go, things can be improved, right? Filtering, better crossovers, better frequency response, dampening effect is another one. And you know, when you're an audiophile, you're probably listening to these terms and they're rather ear catching. Like I said, improvements can be made in these areas. Improvements can be made in many areas, but those are really the ear catching or the eye catching things that you're probably looking at. Okay. So I want to start off by saying this IRS 2092S digital audio amplifier or whatever. It was initially went into production in 1999. Okay, so you need to keep that in mind. When it went into production, it had late 90s and then early 2000s tech in mind. Okay, and as we saw, the recommended QG or gate charge was no more than 40 nanocoulombs. And barring late 90s, early 2000s circuitry design, most often what you probably pair with it would be like a MOSFET, like an IRF 6645 with gate charge of 14 nanocoulombs and supply voltage of, say, plus or minus 45 volts, or an IRFI 4019 with a gate charge of 13 nanocoulombs and a power supply providing plus or minus 70 volts. You know, and that's to provide, you know, 200 to maybe 300 watts amplification over a 4 ohm speaker or driver, whatever you want to call it. But wait a second. This is 800 watts over 8 ohms, right? So what does that mean, really? Well, 800 watts, if we were to do some math, and these are just numbers, you plug it into an equation and it can give it to you. We'll use this as an example. You're talking roughly 80 volts, 10 amps current over an 8 ohm coil. Okay. Doesn't our supply provide 75 volts at max? Okay. Digressing. Or 800 watts, 56.5 volts, much lower voltage, at 14 amps current draw over a 4 ohm coil. Okay, so why efficiency? Why go to 8 ohms? The only logical thing I can think of is efficiency, right? Get the current down, so drawing less from your mains AC. I mean, but really, I think you need to find a better balance here. Efficiency doesn't always mean better. Okay, even in the world of Microsoft and IC processor making, they're ditching now their efficiency cores and just putting in power cores into their processors, because efficiency, that's all it's there for, is to save you on energy. Well, you want to consume energy and change that energy into something else, like a sound wave. So you need power to do that, right? But it's just some things that are going through my head. Well, the IRS 2092S, it can be paired with an IRFB 4227 like we see in this application. And but you would need to compensate for that disparity with the gate charge, because the 4227's gate charge, I think max was what, 98 nanocoulombs, significantly greater than what is the requirement max of your 2092. So how do you do that? Well, in order to do that, you need something like a gate buffer, maybe like a TC420. Okay. You might also want to drop your, if you're using one, your power supply voltage down to 63 volts. Okay. And, setting the threshold for your max output voltage, your peak to peak voltage going to the driver or the voice coil at, 48 volts. And that's where you would have clipping occur to or soft clipping to start cutting back on your input sound amplification. But still, when you do that, you're talking about what, 750 watts over 2 ohms or 500 watts over 4 ohms. But we're saying here 800 watts over 8 ohms. Okay. So in my head, and maybe I missed it, I'm not seeing a buffer. I'm seeing supply voltages of 75, and don't get me wrong, the 42-270, when you look at the gate to drain, source to drain, or whatever the voltage is, it's well capable. But you've got a thermistor that's supposed to be monitoring how much heat your MOSFETs and that transistor is producing. So it's not even inside the casing what would be heat sinking those components to the board, and there is space for it. It's outside of all that. So how's that heat transferring over to that thermistor to monitoring for overcurrent? Because it's an excessive current that would cause the 2092s to cut back on amplification. Mind you, there's not even a buffer, so it's already cutting back before the MOSFETs have time to fully conduct, if they're conducting at all. So what if you just have low-level audio and your potentiometer maybe low to mid-range, and it's powered on by your audio receiver, your AVR, right? Because it's got that audio sense to it. And sure, at low-level audio, mid to low amplification, maybe it can operate perfectly fine. But the minute you crank that up a bit, okay, kind of want to test the waters there, and you start overdriving it. Well, if you continuously do that, I think you're going to have a problem. Moreover, let's say you forgot you cranked it up a bit, okay, and I'm being as nice as I can possibly be about this, and then you forgot you cranked it up after doing a demo for your friends. You powered everything down, and the first thing you turn on, you forget what your volume's at and everything else, and it's just immediately slammed trying to amplify, and your 2092 is already trying to cut back, and your MOSFETs aren't fully conducting yet. I mean, this doesn't sound right, does it? Getting no buffer, 75 volt power supply, 800 watts over 8 ohms. All right, so I want to use this analogy for you, okay? Pretend you're back in high school, if you're, late Gen X, Zennial, early millennial generation, right? And you've got your 1999 Ford Escort dual overhead cam, right? This is your car, your first experience of freedom. That's your A and B. It's getting you to and from school, to and from your after school job. And the things you do in between when you're not doing those things, hanging out with friends, for myself, going to the beach. But, after a while, your Ford Escort just, let's be honest, they're not pretty cars by any means. So you're looking at ways to improve it. You buy a body kit maybe, or LEDs, and you try to make it flashy. Well, this is your filtering per se, your crossovers, your frequency response, your deadening factors, all those things that go, ah, man, would you look at that? That's a Ford Escort? Oh my gosh, that thing's pretty nice. But still a 1999 Ford Escort. Okay. And then finally, as time progresses and you still got this car because it's your first car and therefore your first love until you meet your second love, maybe that's your wife. You'll still have that vehicle, it's a family vehicle, still flashy, still driving it to and from work, right? And you finally throw caution to the wind and you look at your wife and you say, this car needs a new alternator. Of course, in your head, that's your excuse for buying something like, I don't know, turbocharger. And so you buy that turbocharger and you give considerations to needing to punch the oil pan, supplying the oil, intercooler, those kinds of things, right? And you get it all up and you soup it up to provide what? More power? Okay. But it's still a 1999 Ford Escort. You following what I'm saying now? So it really doesn't matter if that 1999 Ford Escort here in 2024 was still being produced at the factory. It's still a 1999 Ford Escort. And if you say one day you're just like wanting to showboat a little bit, and so you punch it. You throw your friends in the vehicle into the back seat on a front wheel drive vehicle? Can't remember at this point. And maybe you throw caution to the wind and you just keep doing that time after time. Maybe not. Maybe it's just a bunch of average driving and then over one day, it just quits on you. Okay? Well, come to find out, the gears, the gaskets, everything else inside of that motor, either plastic or whatever it was being made out of, couldn't handle the additional power, additional induction, etc. Because you really just didn't think about compensating for all the T's that need to be crossed and all the I's. Okay, well, in this regard, I believe that's what this amplifier is doing. Okay? And so maybe it'd be more appropriate to slightly undervoltage the MOSFETs, get that thermistor into the housing, as I've stated in the past, provide a buffer IC, but it just seems to me that this amplifier isn't really designed for longevity. Efficiency, sure. Longevity, no. I would recommend sticking with an A and AB amplifier. But that's my personal preference. And so what is the outcome of a failure in this? Well, you saw it on my channel. The failure occurred before it got to me. It blew the guy's voice coil, his 8-ohm coil. And I put it in here up on my bench, thinking that maybe it's just a speaker that was blown, not thinking to myself, why did it blow? I'll just test out the amp. Everything will be good to go. I'll package this thing up and get back to him, since he's already discovered that his speaker is blowing. And so I've got the gain set, a little bit above minimum, probably about a quarter of the way up. Got my oscilloscope hooked up. Same thing I do with everything, without really thinking of the additional precautions. Throwing it up on my isolation transformer variac dim bulb tester. Putting an 8-ohm load across the speaker terminals at the output. Maybe start putting a isolation transformer from my SIGGEN to the input of these things. Just some additional levels of protection. But just with that little bit of gain and that immediate turn on, because I turned on the audio, we saw it, that at the bottom of the screen where you saw my SIGGEN, that display just immediately gone. My SIGGEN was out. And then you didn't see it on display because you saw, I think, a straight line, but I saw a sine wave, and it went from this, the amplitude, to, it was out of bounds, or at least out of the boundary of my display. And then the display started turning white, and I'm like, I fried this thing. And that's my mistake. So where's the failure in this? Well, the MOSFETs are cooking. Like I said, I think there's some design improvements that need to occur here. And when those MOSFETs and transistors or begin to fail because of the design, they start drawing excessive current, and things that are there like a 200 ohm 4-watt resistor across the not the base, the collector of the transistor going to ground, start shunting voltage, more and more voltage. Well, it's got to go somewhere, especially the plate or the chassis, right, where all the boards are sitting on, is acting as the ground, and then it's not three-prong ground coming from the AC main supply over its cord in. So it's got to find it somewhere. All these things that are charging up, say the chassis is starting to act like a capacitor and collecting all this charge. I hook my SIGGEN to it, but it's found its ground through the SIGGEN because it is three-pronged to actual earth. And maybe something occurred there and that blew the input, which begs the question, when these things fell, are they blowing the pre out for your subwoofer on your AVR? I mean, that's the real risk, right? I mean, 1400 watt subwoofer versus a 1400 watt, and I've got my Denon is, I think it initially sold for somewhere around 1600, 14 or 1600. But I guess that's the risk, right? But we need to be efficient. Well, we also need to design things with a little more precautions. And I also believe we need to design things for longevity. But, that's not going to make a company any money. So that's really my final thoughts on this. You supercharged your audio amplifier using an IC that's designed with 1990s, 2000s tech. Still good IC, great IC, right? 2092 is a great IC. But you beefed up the power supply and you paired it with the 4227 MOSFETs. You're not really giving consideration for longevity, so you 75 volts. You're going across 8 ohms versus 4 or 2. Okay. So you blow your motor. And when you blow it, you take a step back and go, well, where did I go wrong? Well, I think you know where you've gone wrong in this regard. So that's not to say that Klipsch is necessarily the worst brand in the world, and I get it. Class D seems to be the way of the future. If it was a power supply issue, yeah, I'll repair that all day. Maybe some things on the actual Class D amplifier board itself. I mean, I can, by all means, swap out the transistors and MOSFETs. But based upon what I'm seeing in a very cursory, mind you, inspection versus, a bench inspection with all probes and test equipment hooked up to monitor this thing and drive it to failure, which I don't have the time for, to be honest. With a very cursory inspection, there's just a few things that don't come across necessarily right in the design for me. At least leads me to question things. And then the fact, there's word of mouth of these things, sellers saying they're starting to see this product trickle back in. Videos out there across YouTube wondering why their driver, their woofer, 8 ohm woofer, the voice coil is blown, no longer worky. I think we can say that this is just one of those products out of that line that everyone should stay away from. Now, I'm not saying stay away from all Klipsch products by any means, and I don't mean to offend any employee or engineer over at Klipsch. I mean, I've told you at the beginning, I'm not an engineer, but I look at things and I question things and I start to wonder sometimes. So my recommendation would be to not buy this one at a minimum, right? My preference, if I was a big audiophile, I'd stick with Class AB. yeah, your electric bill might go up some, but you're not compensating for high frequency transformers and pulse width modulation and extra filtering and all that other kind of stuff just to make something sound as close as possible to classic A/B amplifiers. So it's more simple design, easier to repair, and long term better for your budget, in my opinion, even if it's a higher cost up front. But that all being said, thank you for watching this episode of Having Fun Repairs. I hope you enjoyed it. Stay tuned for when I finish up this AM48. I think you'll enjoy that video. If you're new to this channel, please consider subscribing. Let me know in the comment section what you thought of this video. Give it a thumbs up, you know, all that doodly-doo. And then if you're looking for a repair, I throw this out there as much as I possibly can. Go to my video description, look at my Google site, I'll take you to the repair tab. Reach out to me via the email, download one of those request for repair documents. We'll start that transaction from there. Anyways, I'm rambling at this point. Hope everybody has a great week and upcoming weekend, depending on or whenever you watch this video. Take care and goodbye.
Bark?